So these are the answers for outcome 13. Can you do this? Problem number 1, which asks about the volume of the container, and highlighted here in yellow is using the original container with the 6.8 as the radius and the 5.8 as the height. And when you simplify this, it's 842.55. And then the part that's in green asks when the radius is doubled. So you have to take this 6.8 and multiply it by 2, and that now becomes a radius of 13.6 squared as a part of the formula times 5.8, which is the same height, and also multiplying by pi. So you should get 3070.20. Pause the video, check your work, see how you did, and then come back. The next question is about a snow cone and the volume of this cone, and it provides for you these two equations, one for the cone and the other one for the sphere. So all you're doing simply for the cone is plugging in that the radius is 3, and that's because they give you this whole length here, which is the diameter, and that's 6, and so you take half of it to get the radius, and they give you the height, which is 13. So even though the diameter is given up here, looking like it just goes with this hemisphere or half of a sphere, it actually also is the same distance across the top of this cone if we were to, think about taking out that snow cone part. So multiply these and you should get 1.2252. And then you come down here to your hemisphere formula, and you can see that it's 4/3 pi r to the third power. And so we've got the same radius, just plugged it in, and this is the value of the sphere, but it is a hemisphere, it is part of it. So you have to take half of that number, and that's 56.548. Add these two things together, and you come up with 179.068, which is the total volume of the snow cone. Pause the video and check out your work and make any corrections that you need to, or just go on to the next one if you're ready. This question asks about using the volume of a shape to determine the values of unknown dimensions. So this is one that people have had some challenges with, where instead of you finding volume, you have to work backwards. So it gives you this volume here that's 21, and the formula for volume of a pyramid is 1/3 width times height times length. Okay, so all I'm doing is plugging in the stuff that we know. We know that the bases are both 3, but we're looking for this height. So I'm just going to plug in these 3's where the width is, where the length is, and I'm leaving h because we don't know what it is. You simplify this down when you multiply 1/3 times 3, that's 1, and 1 times 3 is 3. So now we have 21 is equal to 3h, and then you solve for h by dividing both sides by 3. So our height should be 7. Okay, the next question talks about defending the formula for the volume of a cone. So a cone, if you were to think about it in reference to a cylinder, a cone makes up 1/3 of the volume that a cylinder does. So that's where they get these formulas for, that's where these formulas come from, because the formula for a cylinder is pi r squared times h. And so all that's being done here is just 1/3 of the volume of a sphere is what the cone makes up. So that's where the 1/3 comes from. Okay, so if you were to fill up a cone with water and dump it into a cylinder, it would only fill up 1/3 of this cylinder. Okay, so again, that's where that comes from. And the pi r squared comes from the area of the circle, because that is the formula for the area of a circle. And then you're just multiplying by this height. So that's where the pieces of this come from. Now, the next one is a little bit more challenging, because in defending the formula for the surface area of a cylinder, we're going to break it down into the pieces. So this circle comes from this top part of the cylinder, and then this other one, of course, comes from the bottom one. So if you were to, slice off the top, here would be the first circle and the second circle. And then if you were to, cut down the cylinder and roll this out, then you would have this rectangle. And so the area for a circle, as we discussed up here, is pi r. You got pi r squared. And you have two of them because, just fill these in here. So that part of the formula makes up 2 pi r squared, because there's two of them. And so what's different about this rectangle is that our height here, let's call this one h, corresponds to this height here, which is h. And then we've got to figure out what this length is here. So if you slice open this rectangle and fold it out, this length here represents the circumference around the circle. Okay, and the circumference around the circle is diameter times pi. So again, this length here comes from the distance totally around this circle, which is called the circumference. And that's measured by diameter times pi. Or it can be written as 2r times pi. And then to get the total area, you continue to multiply that by that h. Okay, so to get the total surface area, you add these two things together. So we've got two circles, that's 2 times pi times the radius squared. And then you've got the area of this rectangle, which is height times what this length is, what this distance is. And that distance is the circumference of the circle, the total distance around it, and that's measured by a formula, distance times pi. And diameter times pi. And diameter is the entire length across, and sometimes it's written as 2 times the radius, so those two things are interchangeable. So that's defending the formula for the surface area of a cylinder and defending the formula for the volume of a cone.